Good afternoon, everyone. We're going to continue our look at water today, and we're going to start by going through our questions from last class. So hopefully you had all of these finished for homework. Please get those out. Maybe pause the video and grab those. So, answer to question 1, what percentage of the water on Earth is fresh water? That's about 3 to 4%. Okay, is fresh, and then if you want liquid water, it's much lower. I think it's less than 1%. Okay, but 3 to 4% of water is fresh water. Two special characteristics of salt water. Well, it has two things you can write. It has a higher density than fresh water. Okay, that's an upwards arrow, and it also has a greater buoyant force. Sorry. Okay, two things. There may be some other ones you can write down, but those are two easy ones that come to mind. Why are we having desalination? Well, the main thing is we need to grow crops, okay, for food, and we just need to give people water to drink. Okay, and the main reason we need both of these is because, or we need more of these, is because we have a rising population. So more people means more food, so more crops, and you also need more people we have to provide more water for people to drink. Briefly describe a desalination process. Well, anything where you heat water, and you collect condensation. LLECT, collect condensation. Okay, what can make desalination expensive? That would be the energy to heat water. And finally, name two renewable energy sources. That would be solar and geothermal. Okay, they can both reduce the cost of desalination. So, a reminder, we're looking at water quality, and our essential question is, whose responsibility is it to keep the water clean? Today we're going to look at some things that can make the water unclean. So we're going to look at the contaminants in water. So what can make water not clean, okay, or not drinkable? It's not just the salt this time, it's other stuff that can go in there. So looking at this picture, when we think of contaminants of water, we often think of, really horrible things, like all this pollution, these plastics, this kind of dirt, all that stuff. But not all contaminants need to be, utter filth. Of course, they are a type of contaminant, but contaminants don't need to be that obvious necessarily. So today we're going to look at what contaminant means. We're going to look at some different examples. We're going to look at the two main types of contaminants, so the chemical contaminants and biological. We're going to look at the sources, so what can produce them, and what effects they can cause. And to do that, you're going to be completing a cross-classification chart. So a contaminant, I kind of liken it to a weed. Okay, a weed is just a plant that grows in the wrong place. Okay, so in a similar way, a contaminant, they don't have to be bad chemicals. What they are just something that you don't want. Okay, so they're often useful chemicals just in the wrong place. So our definition that we'll use is an undesirable substance in a mixture. So something you don't want. Why contaminants can be so important is that plants equals food. Okay, either through us eating the plant or us eating the cow that eats the plant, we will in some way consume it. And even if we don't, it will definitely go into some living things. Okay, animals through drinking it directly, or plants through their roots where they'll absorb the water and anything else that goes with that water. Okay, and if those chemicals, if the contaminants are poisonous, that can cause damage or death even to our living organisms, and the little ducky here might be very sick. So this is the chart I would like you to make while going through this video. You will need more than 3 rows, okay, so don't just put 1, 2, 3, that's my whole page. I don't remember the number, I think it's like 5 or 6, maybe even more. But then leave space for the source of the contaminants and the effects. So maybe just pause now, make that table, and then click play later on. So the first source of contaminants, and it's probably the major source, if you had to only study one for your quiz and only one to remember, farms would be probably the most common source. The reason is, farms need to produce a lot of food. We want to make a bucket load of food. To do that, we need to add things to the ground or to our plants to help them grow a bit better and to keep them safe. So if you think about it, we're going to add stuff, so plus growth. So add things to help the plants grow better. If you think about the scarecrow here, what the scarecrow is trying to do is scare away things that would eat our plants. So what we need is, we don't just want big plants, we need to have less or fewer pests. So fewer things that will eat it. And the last thing we need to do, if you think about your growing crops, you don't want anything else to grow in there. You don't want any weeds or any other plants. So you need less weeds. Okay? And the thing is that in farms, we will add different things to our farm to do each one of these things. So we add something to make them grow better, add something to stop pests, and add something to stop weeds. Those things are the names that you see in front of you. So herbicide, if you think about herbs, are like plants that you can eat, okay, or plants in general. So a herbicide is something which kills plants. Fertilizer, you guys know, they help plants grow. And lastly, pesticides, things which kill pests or the animals which will eat the crops. So farmers will spray those or add those to their plants. So that's not necessarily bad. But what they also add to their plants is water. And you guys should already know where that water will end up. So through our water cycle, we know that all the rain, all of this rain that falls, is going to end up in a river of some sort, and eventually the ocean, or through groundwater, okay, it will enter the ocean as well. So all of that stuff will somehow make its way into a lake, a river, or an ocean of some sort. So next, this is a picture of the Colorado River before and after a major spill. Where those chemicals came from was a mining site. Okay, it was an old gold mining site that filled up with a bunch of heavy metals and other chemicals, and they eventually overfilled and spilled into the river. But other sources, salt. Okay, so if you drain, salt isn't a source, but by draining an aquifer, okay, as that water level gets lower and lower, it leaves behind salt in the soil. So that can cause the salt, which is not a bad thing, but if it's in your soil, plants do not grow very well. In cold countries, they also add salt to the roads because salt helps water melt. So if you don't want ice on the roads, you add salt, it'll melt away the ice, but it'll also be added to the water. Like I said before, these industrial sites, mining vehicles, can add a whole bunch of chemicals to the water. So things like oil from your engines or oil spills, heavy metals like from mining sites, or just from pollution can cause acid rain. So it can turn our water slightly acidic. Lastly, because we have so many roads, so many ships, so many trucks going around, obviously the ships aren't going on the roads, they're going in the water, but they're carrying a whole bunch of chemicals. And if those ships or trucks have accidents and spill those chemicals, they will obviously be released into the water. Okay, even if it's in a truck on the road, eventually rain will leak it into the groundwater. So biological contaminants, what we were just looking at previously, are called chemical contaminants. They are non-living things. Okay, your pesticides, your herbicides, your oil, those are non-living, and they're not even from living things. Biological contaminants are things which are they either are living, like microorganisms, so these are living, or they are made by living things. So that should be chemical waste. Sorry, that shouldn't read chemical waste. That should just read organic waste. It may read chemical waste in your book, but I think organic waste is a better way of saying it. Basically, poo. Okay, so that waste, it isn't a living thing. Okay, but it is made with it's something that was produced by a living thing, and a major source of those is sewage. So if you have places where the stuff from your toilet is going straight into into a river or into an ocean without being treated, okay, we'll look later on at how we can treat that in another class. But if it's going straight in there, we may get plenty of well, that would first of all cause plenty of organic waste, because that poo is actually going to be in there, but also a whole bunch of bacteria, okay, because they will grow well, they eat all of this organic waste, so they often go together. Cattle and cattle farming basically are sites where you have a whole bunch of organic waste being produced, and of course a lot of bacteria will go along with that. So let's look at some of the effects that these contaminants can cause. First, we'll look at fertilizers. Now, the aim of fertilizers is to grow plants. The problem is they will grow any plant that you apply them to. When they end up in the water, they cause the growth of these very simple, very easy to grow plants called algae. So these are the things in your fish pond or your fish bowl that will make it look a little green or a little slimy. That's the algae growing. And so you can see in this picture here, all of this green stuff here is algae. You can see it's completely covering the surface of the water. And that's not necessarily bad initially, but the thing is, all of these algae, so if we have our pond here, here's the water, we have fish at the bottom. Remember, fish need oxygen to live, and that oxygen is in the water. It's dissolved in the water. What happens is, if we have our algae growing on top, okay, that's not too bad. But when these guys die and they start to break down, so I'm going to turn them red, they're starting to break down now. The process of them dying and decomposing actually uses up oxygen, because the bacteria that eat them, that decomposes and breaks down the algae, they like oxygen, so they use it up. What that means is little fishy here has no oxygen left in the water, and so we end up having a lot of fish death. Okay, you can actually kill entire populations of fish. Herbicides, pesticides, and other toxins, we'll lump those into some general effects. If you think about it, pesticides are meant to kill certain animals. If they get into the water, well, they might harm some other animals that consume that water. Same thing with herbicides. They're meant to be toxic to life, just plants, but they can hurt animals too if they consume them. So they'll cause these things, and other toxins as well. So anything else that's poisonous really can cause harm to other animals. Specifically, one particular type of pesticide used in the 80s, DDT, was very successful in killing mosquitoes, flies, and beetles. However, it went in the water and it was consumed by many birds, and it caused their shells to be extremely thin. Okay, and so these birds, their babies weren't being born because the shells wouldn't provide the strength and the protection it needed to. Okay, so this is a case where the full effect of DDT was not known. The full effect it would have on the environment and other animals was not known. And it's taken decades for the population of those birds to bounce back to healthy numbers. So, salt. I mentioned before about the relationship between salt and groundwater levels. So, what can happen is trees often soak up water. Okay, so they keep the water table nice and low. Remember, the water in that aquifer often will have a lot of salts in it. Okay, it may be fresh water, but it might carry some salt from its way down. Okay, when it falls through the soil, it may pick up some salts. What can happen is if you clear all of these trees, they stop soaking up the water. So they stop soaking. Because there's nothing soaking up the water level rises. And what it does is, as it rises, it takes along any salt it finds in the soil. So all of this salt here is getting taken up higher and higher. And when it reaches the surface, okay, it's going to make that surface very salty, obviously. What that means is all these crops and plants which want to live in that top layer of soil, well, there's a whole bunch of salt in it. And if you've ever eaten something too salty, you know it makes you very, very thirsty. And it's not a very pleasant thing. That can happen to plants as well, or a similar thing can happen. And so, by salt, we have crops dying, and can actually cause lands to clear entirely, or land to clear entirely. Okay, you can have whole areas which we call salt lakes, where they're basically just a whole bunch of salt. Okay, not all of them are caused by this type of thing, but some are. Acid. This one is a little obvious, right? Like, you know that acid is harmful if it gets on your skin. Now imagine if you are a fish or an aquatic organism that lives in water. Okay, and now your water, your home, is now acidic. Okay, obviously that's going to cause a lot of harm and death to fish and things which live in the water, also to plants. Okay, where they'll be, you know, to some level drinking that acid. But one other thing you can do is, because acids like to break down certain chemicals, they make those chemicals, okay, they'll break them down, and it'll be easier for those chemicals to move in the water, or to become dissolved in the water. This is a picture at the bottom showing you, this is the most acidic in the middle. And this one on the left is the least acidic. You can see in the most acidic plants, the roots are incredibly short, whereas in the least acidic, they're meant to be right down here. So just an example of how much damage acidic soil can do to those plants. Heavy metals. The problem with heavy metals is they build up. Okay, we can't digest them, we can't excrete them, so we can't like pee them out or anything. They just stay. Okay, and when they build up, they cause a lot of harm. So things like organ failure and death. You look at what happens in this plant on the right. They're meant to look like this, but when they have a lot of this is manganese, I think. That's a metal. Okay, its leaves are much more shriveled. They're not healthy, and this plant is not going to do very well. The main problem with heavy metals is because they're not digested, they're not excreted. So anything which eats something that has metals in it will absorb those metals. So if a cow munches on this this leaf, guess where all that metal's gone? It's gone into the cow. And then when you go eat a steak from that cow, that metal has been passed into you. And you may then develop, hopefully not, but there's a chance that you may go on to develop some of these symptoms and have that harm from that metal, those metals being in your body. Now we'll look at a few biological contaminants, starting with microorganisms. The main thing they can cause is disease and death. Okay, think about having food poisoning, except it's from your water. Okay, and this may happen, constantly. In fact, diarrhea is the leading cause of child death. or child mortality in the world. If you look in most of these continents here, or regions, in Africa, almost or over 40% of all childhood deaths are due to diarrhea. And in Southeast Asia, where we are, about 37-ish% of all childhood deaths are caused by diarrhea. And often that is due to bacteria, microorganisms, being in the water. Lastly, organic matter. It's a very similar process to the algae, except these guys will provide food. So organic matter is very, very similar to food. Okay, so as it breaks down, so as the bacteria break it down, they use up all the oxygen, and so all the sea life that needed to breathe in that oxygen, not breathe in, but to absorb that oxygen, they can't do it, and they will die. Okay, so hopefully you'll be able to do these things. You'll be able to define contaminant, and give me some examples, state the sources of chemical and biological contaminants, and list or briefly explain their harmful effects. And hopefully you've completed that cross-classification chart. What you need to do now is complete the table from chapter, so complete the table you've been working on from the chapter. So don't just go with what I've said, read through the text and fill it in. There is a table which is very, very similar. It's a little bit more complicated on page 294 for the chemical contaminants and page 295 for the biological contaminants. And then once you're done, answer the Check Your Learning questions on page 295. If you have any questions or anything like that, please let me know by an email or comment on a Google Classroom so I can see your question and answer it. Okay, thank you very much.